Okay, so we're officially underway here. This is the Basketball Analytics with our workshop. I really enjoy doing this. I got a chance to do this last year. This is my second year. Few logistics before we really get started is just for logistics here. I have everyone muted when you come in. I do have access to the chat if you have questions there. I also plan to have a little bit of time at the end for questions where I can actually unmute you, if you have a question. So I hope, given this format and the potential number of participants, I hope using the chat and then maybe trying to individually unmute people with questions will work for everybody. And last year, I thought we had a really nice discussion. So I hope some of the things you see today, are interesting, and as we go along. And I guess the other thing I would say is this is scheduled for 50 minutes, but I'm keeping the WebEx event room open for like 2 hours. So I love doing this stuff. So if for some reason there's a ton of questions, I'm happy to stay on afterwards. So I just want to say that before we begin. Okay, so this is the agenda for today. It is, so if this is your second year in this workshop, it's similar to last year. I've updated some of the statistical case studies with the most recent MBA season. And I've done some updates, some edits, but I think there's enough material here where it will be, new. And certainly if this is your first time at this workshop, this is your first year, then I think a lot of this, hopefully be useful to get you started and get you well on your way to doing some cool basketball analytics. So I'm going to talk quickly about this package, BasketballAnalyzeR. Pretty much everything I've put together in here was done using this package. It is really easy to install and actually very easy to use. And what you'll see as I go along, I focus a little bit less on the actual R code. All that stuff's out there on the GitHub website. And I think, there's enough comments, hopefully, where you can kind of get up to speed. And I want to talk a little bit more about like the analytical side and maybe how to use some of this output and, how you can use R to get what I think is some interesting visualizations and try to tell some interesting stories. But everything under here is with this package. So I'll talk more about this package. And I do spend a couple minutes about how to get some data. So there's also some code out there to help you get some data sets on your own to start, really playing around with this and really focus on whatever you find interesting. And I kept this in here from last year. I want to just talk about some like fundamental basketball statistics. I'm kind of under the assumption there might be a wide range of students. So I think even some of these, quote unquote basic statistics are worthwhile to review. And then the vast majority of today's discussion will be case studies. And I think this really highlights the package. It highlights that there's really, some neat stuff that you can come up with this package. And most importantly, how you might interpret that and some things to be careful with and some things to, really think about and hopefully kind of pique your curiosity for some of the things you can research on your own when we're done today. So without too much of a delay here, just to get right into it. So this is the package BasketballAnalyzeR, and I got introduced to it through this textbook. It's textbook wise, it's not that expensive. It's available, I think, on Amazon or through the publisher. And the great thing about it is it walks through kind of some introductory material about a specific statistical technique. And some of the things in here are pretty advanced, like machine learning, network analysis. We'll talk some about some of that stuff. But it also walks you through the R code and you can really do it side by side. So if you're kind of brand done basketball analytics and maybe other software like Excel or stuff on your own, you want to use R, I really can't say enough good things about this book. There's, kind of website links here where it has some supporting material online. And, I just want to make sure I get this out of the way because this was my major reference in building today's presentation. So when we talk about this package, so the nice thing about it is, I'm assuming most people here are pretty familiar with R. You have a lot of built-in functions that do a lot of the hard work for you. And, a lot of these we'll be using today, like shot chart, 4 factors, assist net, expected points. These things, you just have to understand how the functions work enough where you need to put the inputs in, and then you get output. So the huge advantage of a package like this is with very little initial effort, you can do a lot quickly. Of course, as you get more seasoned, some of the downsides are you are a little bit constrained in what your output might look like. And that's when you get a little bit more advanced. You can kind of dive into the actual underlying code for these functions and maybe edit them or see how they work and then write your own functions. But the reason I like this package, I want to highlight it, is like it's just so quick to get up and running and doing a ton of stuff that I think it's certainly worth a look. And like all good R packages, it includes preloaded data sets for which started to become kind of a long time ago, the 2017-2018 NBA season. So this is what the textbook itself references. So again, you don't have to spend time like digging for data, trying to figure out what's going on. You immediately have these in front of you. You can open them in R. You can see what the data input looks like. So then when you bring in new data, you can model it to be able to use these functions right away. So it's a very easy package to use, to get started with. It's kind of self-contained. And I mentioned this at the top, but I'll re-emphasize that if you go to the associated GitHub website for these slides, you'll see all of the code I used in last year's presentation, this year's presentation. It's totally free. You can just jump out there. You don't need a password. You can just download the R code yourself, and you can even run these alongside with me, or keep the slides to the side and try to recreate the figures. There's a little bit of a nuance I'll talk about later, but I think with this package, with the introduction of today's presentation, and with the code on this website, I think you'll really be up and running pretty quick, and you can do some neat stuff. A little bit of a sidebar. I wanted to update a lot of the data from last year. So as I'm sure you know, or you'll find out soon, a huge part of like data science, data analytics, whatever you want to think about it, even just statistics in general, is trying to find good data. So there's some other workshops on that. For MBA specific, I found this other package, MBA Stat R. It's not as, when I did this presentation, I think it was in August, late August, it wasn't out on the CRAN, I don't know what you call it, repository yet. So to download it, you need to, and install it, you need to do a little bit of like a circumvention, which sounds overwhelming. It's really not. If you go to this website, they walk you through what to do. So it's pretty easy. It's just not one of those things where you can do installed.packages. As of when I did this presentation, worth another look. Maybe it's up there now. And the reason I mention this is I used this package to update team and player box score data. And that code I used to update the team and box score, player box score data, as well as get it into a format for this BasketballAnalyzeR package, is on the GitHub website. So that's a little more of the nitty-gritty stuff. But if you want to get data, you want to get started, there is code out there. One thing I learned going through this process is the MBA uses a game ID, which, I mean, most database management, you need some type of unique identifier. This is what the MBA uses. And once you kind of get familiar with this lingo, you can update some of the entries for this package here, NBA Stat R, and you can get preseason data if that's what you want, regular season, all-star games, playoffs. So you can kind of set that prefix, and then you just type in the year you want, and the games are individually numbered for, this is for a regular season. So if you have 30 teams, 30 times 82 is, it's going to be twice this. So that is, I think, 2460. And then obviously 2 teams play in 1 game. So this is the total number of individual games per season. And, through this package, you might have to do a little bit of manual inputs as this package is still under development, but you can get, any season you want back as far as, can't remember the start date when this data was freely available, but the NBA.com is pretty exhaustive. So you can get, a lot of season stuff that you're interested in. You can focus on postseason, whatever, but this is like a framework to really get you any data you want if you, in conjunction with this package. And then I'll also mention the play-by-play data is a little bit different. I personally went out to this website, this bigdataball.com, and I just paid $30 for a single season. The nice thing about it is it already matches the format for BasketballAnalyzeR. And I know, when I was an undergrad, I used to be vehemently opposed to paying money for anything. But if you really think about it, $30 is very cheap for the amount of time you'd have to spend to find the play-by-play data, and then any editing you'd have to do to get it into this package. So I mention this because I paid this money. I got the play-by-play data for the most recent season. The only downside for you as an attendee is I did not include this data on the GitHub website because it is behind a paywall. But if you want to replicate some of the play-by-play stuff, I would point you to my GitHub website and see last year's presentation where I used the 2017-2018 NBA season. Or, just kind of pay the $30, which, just think about your time here. It might be worth it. So this is just a, quick aside about how to get data, which, of course, is a very important part of doing some, cool analytics. All right, so let's start to get into it. We'll dip our toe here into some basketball analytics. These are, not, I guess what I would say, sexy by the machine learning criteria and stuff like that. But this is a paper from 2007. And if you are a fan of ESPN.com, you read some of their stuff, you might recognize Kevin Pelton, his name. He was one of the authors on this paper. I think some of the other people on this paper have worked within the NBA, some teams. And this is some early, what they've called a starting point for analyzing basketball statistics. But this is where they tried to get a little bit more into some of the, nuance of how basketball is played and some of the rules. And again, looking at it from a lens of 2021, nothing here is extraordinary, but this is kind of like the first step. And something like effective field goal percentage, I'm sure you've heard if you've listened to a broadcast for an NBA game or you've done some reading, but it really just takes into consideration that, well, some field goals are worth 2 points. So we should take a weighted average of your makes where, if you shoot 50% from 2-point territory, it is not as valuable as shooting 50% from 3-point territory. So just something simple like this was actually like a start of a huge change in the way the NBA was played. And I think most people are aware of this if you're at this conference, that a lot of teams emphasize 3-point shots, and it really just kind of starts with like a slight adjustment of something as simple as field goal percentage. Rather than just take all the makes over the misses, think about weighting it, where you give more valuable makes more weight. And, similar stuff here, like turnover ratio. How many times do you turn the ball over versus how many possessions you have? And then you can look at this, on the defensive side where you just flip it around. these subscripts, this T is, you could think of it like your team. You could think of the O like opponent. And then other things like rebound percentage, how many rebounds are you grabbing and how many opportunities for rebounds are there? Again, this is right. This is a little bit different than just counting the number of rebounds. And free throw rate. How many free throws are you making, not just attempting, are you making versus how many shots you take? And some of these things can be very useful because they're measures of like efficiency. How efficient is your offense? Are you taking the most valuable shots? Are you avoiding giving the ball away? Are you good at finishing possessions and getting rebounds? Are you are you putting yourself in position to make free throws? On the opposite end, are you putting yourself in position to give away a lot of free throws? So I just put this here because, when you hear sports analytics, you might immediately default to some of these, very detailed, even exotic looking like visualizations. And we'll certainly do that today, but don't forget that some of these like foundational things, just doing this, taking ratios, being a little bit more thoughtful about how you present basic information, is still analytics and can still be very useful. So we're going to get into the case studies here, and these are just warm-ups, just to kind of get our I guess I'll say our analytical juices going. And to highlight, of course, the BasketballAnalyzeR package. So this is just a basic shot chart output. Few things right away. You can see like the package gives you this nice outline of a basketball court, and then it creates the there's like an XY coordinate underlying it here, and it measures all the shots. This is built with play-by-play data, so you'll need to either get access to that data set for the most recent season or focus on some of the other seasons. But this is a collection of every shot taken, and you can also keep track of makes and misses, and you can sort by player. So I've given you a little bit of time to look at this and think about, what player this might be in the NBA. And for the sake of time here, this is, well, if you look at this, this is someone who obviously shoots pretty much only near the basket, does not take a lot of three-point shots. If you see this at first glance, you might think that this is, like a center, someone who plays closer to the basket. But this is actually a Ben Simmons shot chart for the most recent season. If you're not familiar, Ben Simmons is a guard, actually. He plays with the ball a lot on the 76ers. And, I think if you're anywhere close to basketball, you're pretty aware that there's been, some commentary that he would be a different kind of player if he was more willing to shoot from outside. And I think you can kind of watch it, you can kind of look at it, but when you actually see the shot chart, I mean, Ben Simmons is a player who really does not shoot from outside, what's known as the paint very often at all. So sometimes a picture can really convey something a lot differently. So this is Ben Simmons. Now this very different shot chart. You see certainly a lot more three-point attempts. There seems to be, a decent amount of blue out here, but there's also some red here too. This looks like a pretty good three-point shooter. You see tons of shots in the mid-range, and the thing that stuck out to me right away is tons of makes. Like this is someone who makes a lot of mid-range jump shots, and of course tons of shots near the rim. Certainly a very different shot profile than player one, Ben Simmons, and this particular player is Devin Booker. So Devin Booker's on the Phoenix Suns. He's known as somewhat of like a mid-range, very, very elite mid-range scorer. You can see that here. There really isn't a place on the floor that he shoots from that he does not shoot very well. And I say that, I guess, in the mid-range. And we'll look at another way to look at Devin Booker's kind of shot profile later on in this presentation. But this is certainly very different. So again, this is not super fancy stuff, but you can see right away, a huge difference between two players. Third player here, you could see pretty much takes 3-point shots and shots at the basket. Almost no mid-range attempts. So you can see here, if you some of the analytics we'll see later about like expected points by shot distance, you can see this is a player who's heard that taking mid-range shots is not an efficient shot for most players, and this is a player who kind of abides by that. So this is a shot chart for James Harden, and I think what I take away from this is so this was last season, so this is kind of part way on the Rockets, but then mostly on the Nets. Is I think we give a lot of credit sometimes to like general managers, front offices about determining what's an efficient shot and implementing a strategy, but I think sometimes we don't give a lot of credit to the players for really understanding what is a really efficient way to play basketball. And there's been a lot of stuff said about James Harden, but I give him a lot of credit because he's someone who I think really understood what the Rockets were talking about when they were talking about trying to play efficiently, and he's doing the hard part, right? He's actually doing it on the floor, and you can see a shot chart like this. This is like an sports analytics dream shot chart here, right? You're just taking efficient shots, shots at the rim, and threes. So very different player profiles. These are all guards. They play very differently. But I think, again, super easy to get this up. And you can plug in your favorite player. You could do a comparison of a ton of different players. You could really start playing around with this. So, and there's different versions of shot charts. You can implement like a time factor, how much time is left in the shot clock. You can include percentages. This is just something to get started with. So switching gears, this is much different type of analysis. And I did this a little bit last year, but I'm going to kind of dive into it again because I think it's neat, and we've updated it with the most recent player information. So what we're trying to do here is compare players who are similar. And this sounds, like a reasonable goal, something we might be interested in. And there's a lot of different ways to get at it. What we are going to try is something called multidimensional scaling. And this is a pretty fancy sounding term, but what you're trying to do is reduce dimensionality in your data set. So I know there could be a wide range of people with statistical backgrounds on here, but I think the thing that helps me internalize this a little bit is if you take in like a linear algebra class and you have your matrix and you have some vectors in your matrix, potentially some of those vectors are redundant, right? They're linearly dependent on other rows. So this is a way to do something sort of similar to try to remove information that is not is like redundant. And in particular, you are starting with like a vector of variables. So it might be like, in our case, rebounds, shots, assists, steals, whatever. You have a full vector size P for one player. You have another player who has P entries. And you're going to come up with some type of metric to measure the distance between the two players. Now, there's a ton of different distance metrics out there. And then if you think about it, you have, however many players, say it's 100 by 100, you're going to have a huge matrix, right? You're going to have like Steph Curry and LeBron James are going to have a distance. Giannis Antetokounmpo is going to have a distance with Joel Embiid versus, Chris Middleton, whoever. So what we're using is a pretty standard measure of distance, Euclidean distance. Again, you think about what's going on here. You have two P vectors. You're taking the difference between each terms. So like 2 players assists, 2 players rebounds, 2 players, steals, whatever. You're taking a square sum, and then you're taking a square root. A couple things to think about with a distance is it should always be positive, right? You can't really have a negative distance. We've ensured that with taking the square root and squaring a bunch of terms. And there's a couple other properties you need to satisfy. I won't get into too much of the details, but you can see right away that this is something that takes a P input vector and tries to turn it into a single number. And that's kind of the goal, right? You're trying to reduce the dimension. You're trying to turn a vector of P statistics into some type of single number. Now, in our case, well, generally speaking, you're starting with P, you're trying to get down to Q. We're trying to do a data visualization, so Q really has got to be either like 2 or 3, or it's going to be really hard to see, or even 1, I guess, because you can compare the size of numbers relative. And there's a lot of different ways to measure how effectively you've reduced the dimension. We're using something called the stress index, and basically that says, how much information do you still have versus what you started with, and how much did you lose? So phrased differently, we have 0% here as a perfect fit. That would happen if these P vectors, these P data points, were all the same, right? Because then they're all redundant. So you're not really losing anything by taking out all the genuinely linearly dependent information. So you just want to avoid getting a stress above 20%, because then you're really kind of changing the information too much. So I know it's a super fast introduction. I think something more interesting is if we actually do this, we end up with this 2x2 plot of all players from last season who played over 1,500 minutes, and our vector of stats is 8-dimensional. It's total points, threes made, twos made, rebounds, assists, turnovers, steals, and blocks. So we could spend a lot of time looking at this. I think this is a really neat display. I am going to talk about a few things I think are interesting. First of all, I think players who I guess I'm getting a question. What do the axes measure again? So that's a great question. There's a question about what do these axes represent, and it's actually kind of hard to interpret what exactly is plotted here. The goal is you have an 8-dimensional input, and then you're turning that 8 dimension into some 2-point coordinates. And the theory is if two players have a very similar vector here of points, threes, rebounds, etc., they're going to be plotted close to each other. So you're trying to go from 8 dimensions to 2. So it's hard to say exactly what this is, other than like a scale of difference. So someone like Russell Westbrook is going to have very high numbers in probably a lot of these categories. So he gets assigned this coordinate versus like a Jimmy Butler, and you try to use this to say these two guys are this different relative to another two guys. So you're kind of getting on one of the things I wanted to talk about, which is you got to be a little careful with the interpretation here. And another follow-up question: do you use dimensionality reduction? I might save that question for a little bit later to kind of dive into that a little bit more. I want to make sure to focus on the material, so I'll save that question for later, Richard. Now, we have all the players thrown up in front of us, okay? At first glance, you see some players that stand way out. And generally speaking, these are players that are like all NBA level players. So your first instinct might be, okay, these players are excellent, right? Like Nikola Jokic was the MVP, right? You have like Luka Doncic, Steph Curry, etc. But you also have like a different side of players that stand out, like Nerlens Noel, Rudy Gobert, Clint Capella. These are players that might be more focused on whether it's defense or they only shoot at the basket, or focused on rebounding, things like that. So it's not quite like a measure of how quote unquote good or excellent a player is. It's just a way to try to get everybody up here in front of us and look at how players might compare against each other. Are they similar or not? You know, is like a Damian Lillard and Steph Curry, right? This is kind of a sniff test. Are they similar? Yes, right? They both take a lot of three-point shots. They're both excellent three-point shooters. So this kind of helps you, hopefully, with the interpretation. I think where something like this could be really useful is if you were thinking about maybe making a trade or trying to find a certain player. Like, so if you're one of the examples I use, say you're a general manager of a team, you want your defense to be a lot better. Well, I know Rudy Gobert is an excellent defensive player. It's very hard to get Rudy Gobert, but maybe I can get a player that's sort of similar to Rudy Gobert. And the guy that jumps out is Clint Capella. And I think the other thing you can try to overlay with this is some of the salary information. So again, I'm not trying to say one player is worth more than another one. I'm trying to make the point that you have players that are similar. Maybe you can find like a market inefficiency, so to speak, and if you compare the salaries of like a Rudy Gobert, he's making $41 million a year just on average, and Clint Capella's when I first did this was making 8, and he actually signed an extension. So maybe his agent saw this presentation or something. But you can see there's a difference in their pay, and they are kind of similar, right? I'm not saying they're as good, but this is something you could try to do to like approximate another player. Some other ideas of things to think about. So, this is another comparison here. You see Luka Doncic and Julius Randle, they're very close together. Again, I'm not making the case that these players are the same, they're as good, but this kind of, I think, highlights that Julius Randle really had an exceptional season, right? If this is where he's coming. And if you're the Knicks, maybe it's obviously it's very hard to get a Luka Doncic. He's one of the best players in the league. But maybe you can try to approximate him with like a Julius Randle, and then that difference in their salaries, that 10 million, maybe you can, use it somewhere else to try to maybe make the case that, okay, if I can have a Julius Randle at 30 million and player Y at 10 million, I can get similar value to like a Luka Doncic at 41 million. Maybe. Something I think it could be cool homework is, Luka Doncic and Julius Randle are very close together, but they're still in some ways very far apart, right? I think most people would, given the choice between the two, you might lean towards Luka Doncic, and maybe you could do some additional analysis to say what's that difference between the two. Like, it's one thing for two players to be close, but if you have two very, very good players and one of them is just a little bit farther, it's like that extra little bit that's really, really, really valuable. So just something to think about. Another thing I thought was interesting, if you take another two players that are generally considered pretty similar, I'm getting a little bit more into the weeds here, but like a Duncan Robinson, right, kind of a three-point specialist on the Miami Heat, a Buddy Hield, also a three-point specialist, but on the Sacramento Kings, you can see they're pretty close together, but Buddy Hield makes a little bit more per season than Duncan Robinson. And again, one thing you could try to argue with analysis like this, you'd have to really get into the details, but because Buddy Hield plays in Sacramento and Duncan Robinson plays in Miami, maybe this is like the premium that smaller markets have to pay to attract similar players. This is like the upcharge that the Kings have to pay for a similar player because they play in Sacramento versus Miami. It's just one, theory. You'd have to really dig into this and try to get at, but I think there's a lot of like interesting questions that just come from one display like this. A few words of caution. I think you have to be careful with the interpretation, and this is the question that Richard had a little bit earlier ago, and just basically saying, what are these axes measuring? And the punchline is, it's kind of like a made up measure of distance. Not made up, but it's based on a formulaic way to compare two things. So you want to be a little bit careful for a couple things. First of all, you see a player like T.J. McConnell down here. He's pretty close to Steph Curry. Now, I think most people would prefer Steph Curry to T.J. McConnell. So one thing you have to do when you see this is you have to do like this initial sniff test. Why is this player coming up like this? My understanding is because I actually wondered this, and when I dug into it a little bit, is T.J. McConnell is actually like remarkably efficient. He really takes shots that he makes. He doesn't shoot at a high volume, doesn't play the same type of minutes as a Steph Curry, obviously, but he shoots a very high percentage from the mid-range. He doesn't miss a lot. He gets a lot of steals. So he's actually kind of a similar efficient type of player as a Steph Curry, but the volume is way different. So you want to be a little bit careful about that. Also, obvious things like you'll see LeBron James's name kind of buried in the middle of all these players. And I think if you follow the NBA close last year, LeBron James missed half the season. So in some ways, it's kind of remarkable that he missed half the season, yet was still basically an average NBA player. But you obviously would want to know something like that because this is on a cumulative type of level. So just small stuff like that. But there's a lot of really interesting things to look at this. So you could try to find your favorite player on here. You could try to make the case for your player versus another player. I know if you were on here last year, I think I compared like Trae Young to Lou Williams, which is not looking great right now. But if you're a big Trae Young fan, you could really use this to say like, hey, look at the players he's grouped with: Chris Paul, Luka Doncic. Like Trae Young is very, very good, or a very, very impactful player. Maybe that's a better way to say it. So I think this is really neat stuff, and I could spend a long time. I want to make sure we get to some of the other stuff, but I think this is pretty neat. Okay, so this is a little bit different. This is network analysis. So this is we are trying to basically plot a system. So there's a lot of different types of network. There's obviously things like the internet, phone networks. You could think about like traffic, right? Like traffic flows through intersections and certain highways, and you might want to measure how many cars go through at a certain time or what might cause accidents. But you can also think of like an NBA team as like a network, and each player is a node. And because we have play-by-play data, we can see who passed to who before they scored. So you get an idea of kind of how the ball might flow around within an NBA team. So again, this is a high-level review, but you take the play-by-play data, you look at players who. So this is what an output looks like. This is the Miami Heat. You can see the arrows identify who passed to who before they scored. And you can see the number of assists. So when it's red, that means these two players connected a lot. So one thing I think is really interesting, this is the Miami Heat. You basically see two major nodes. You see a Jimmy Butler, you see a Bam Adebayo. So their offense really runs through these two players. And it's a little bit egalitarian, split between these two. You see some, like a Duncan Robinson, right? We talked a little bit about him. He's a three-point specialist. You can see arrows pointed at him. He's the recipient of a lot of assists. And that is something you'd expect to see. Kind of similar with a Tyler Hero. Someone like a Bam, right? He's got arrows going out and towards him. So he's someone who finishes plays. He's also someone who initiates offense. Same thing with like a Jimmy Butler. So this is kind of interesting, and maybe so much it's not too informative for one team, but I think when you start comparing teams, so this is the Dallas Mavericks, and you can see their entire offense basically is Luka Doncic. Everything runs through him. All the arrows start here and they go out towards different players, and he, is the number one feeding assist mechanism in this system for this offense. Very different than the Miami Heat. And, for this particular player, I think most people, if just by watching, you could say, wow, Luka really has the ball a lot. But sometimes seeing it like this really highlights how much this one player is doing for this offense. And certainly it can help you kind of game plan for the two different offenses. You're going to have to think very differently about a Miami Heat type offense than a Dallas Maverick type offense. And you can, of course, do this with your team, and you could try to figure out what things look like. And it's just a way to visualize what you might see on video, and even a huge, kind of data set of information you can kind of get up here quickly. Now, this is something else I did last year. It's kind of been updated. I think if you, again, are even like a peripheral fan of the NBA, you've heard somewhat of this idea of tanking, where if you aren't familiar with this, basically the NBA tries to create equity among the teams by, if you were a team with a very bad record, you have a higher probability of getting a very high draft pick for the new level of amateur players coming into the league. The theory being, you have first choice and you could try to get a better player, and that'll balance out the teams. Now, some teams have pretty much decided that trying to get a very high draft pick and getting a player in the draft is our best hope of becoming like a very, very good team. And they almost, they basically try to lose games on purpose. And, I'm making fun of poor Sam Hinkie here. He's kind of become like the poster child of this, but teams are doing this right now. He just kind of got, he was one of the first people to be very open about it. And, but it is, certainly a strategy that a lot of teams use and are using right now. So the reason I say this is, if you're kind of, say you're a general manager at a team and you're trying to decide your direction, should we focus on a cliche rebuild, or should we quote unquote go for it? You might be interested in using statistics, in particular clustering, to see what might be your best option. So what do I mean by that? Well, clustering is a type of unsupervised classification. Unsupervised, you can think of it like machine learning, whatever. And basically what you're trying to do is come up with a criteria, some type of distance, right? We've talked about this concept a little bit before, where everything within one cluster is quote unquote similar, yet different enough from other clusters where they're separate. So, where you see this a lot is like maybe image recognition or something. That's kind of an example where you're trying to classify things. But we could do this with NBA teams, right? There's nothing stopping us from doing that, and we can focus on those 4 factors I reviewed earlier, and we can we'll use something here called k-means clustering. There's a lot more details in chapter 4 of the textbook I referenced, but we can cluster teams together. So this is again, this is based on the 4 factors. A couple things to get our bearings. These are points that your team scored. So if you're in this quadrant or on this side, you didn't score a lot of points. This is points that your opponent scored. So if you're down here, you have a good defense. If you're up here, then you tend to give up a lot of points. And the other thing I think is neat is the size of the ball is how many wins you had. So you can see like the Bucks, the Nets, the Jazz, they won a lot of games. The Houston Rockets won so few games you can't even see their ball, and other teams had smaller amounts of wins. And then you also see the colors. So apologies for anyone who might be colorblind or not able to see the different colors, but there's like, I guess, a pink or a purple color here. There's red, there's green. So you can kind of see who your team's been clustered with. And this is sorry about this. This is a list of the clusters, and we'll talk a little bit more about this. But you can see like the Brooklyn Nets, the Milwaukee Bucks, Utah Jazz, the LA Clippers, they were all in one cluster. You might think of this as like the quote unquote the best teams in the NBA. You could see like kind of secondary clusters, like the New York Knicks, Lakers, 76ers, Nuggets, Hawks, Grizzlies, Celtics. So someone like this, I'm a Knicks fan, I could make the argument. Some people think the Knicks is kind of a fluke. They won more games than they would have in an otherwise normal season, whatever. Something like this, based on the four factors, based on the way they play, would suggest, well, they're clustered with teams like the Lakers, the 76ers, and Nuggets, the Hawks, with good teams. So maybe they are a good team. On the flip side, you might look at this, if you're the Washington Wizards, you won a decent amount of games, right? You have a decent sized ball, and you're clustered with some teams that basically are trying to lose on purpose. So this might point out to you that, hey, you might be a little bit careful about what you decide to do. Like maybe you won more games because of luck, or you got a little bit of a favorable bounce here and there. And actually, I don't know if the Wizards maybe did something similar, but they traded Russell Westbrook. So maybe they also view themselves more of like a rebuilding team. I don't know. And I got a question here. Very good question from Jintao. Are the Chicago Bulls the green color? Answer, yes. So you see the Nets, Clippers, Bucks, Jazz, and the Bulls all in the same cluster. So I thought that was pretty strange. And I would give you two kind of ways to try to interpret that. First, there's no reason you need to pick 5 clusters. That's one of the tricky thing about k-means clustering. You need to decide k ahead of time. And there's actually I'll give this kind of as homework, open-ended homework. You need to, there's a number of different ways to evaluate whether you have the quote-unquote right number of clusters. So sniff test might say, I don't think so because I have the Bulls with the Nets and the Bucks, whatever. Now a Bulls fan might say, well, wait a minute. Maybe it's just we played really well. We just got really unlucky. We had some injury luck, and maybe we are actually much better. And if you look at the Bulls offseason, they did, they signed, I think, Lonzo Ball, DeMar DeRozan. They are, quote unquote, going for it. They're trying to be a better team. And, I certainly want to give teams credit for trying to win versus like what's going on with the Oklahoma City Thunder. But that's my own soapbox. So, and I'm getting a couple of questions here. What I want to do is just try to wrap up in the last couple of minutes, and then if it's all right, I'll answer some of these questions at the end, and we can come back to this. But this is something like you could change the number of clusters. Maybe you do 2 clusters, try to see what the playoff teams should be versus non-playoff teams. See if any team got unlucky, not unlucky. You could see where your favorite team is, and kind of decide if your general manager is taking the right strategy or not. Okay, kind of the last idea here is this this idea of expected points. So again, I know there might be a wide range of people with statistical backgrounds here. We're going to do something called expected points, and that's based on this idea of expected value. And basically, expected value is like a weighted average in a discrete context of you take the probability of your event times the value of that event. So, very loosely speaking, very basic, if we talk in terms of a player shooting a ball, right? 2-point shot, you have 2 outcomes. Either you make it or you miss it. And if you make it, you get a value of 2. If you miss, of course, you get a value of 0. If you're a 45% shooter, then your expected value is the probability of a make times 2 plus the probability of a miss, in this case times 0, but there's no reason it has to be a 0, right? This could be a bunch of different numbers. And on average, this player would get 0.9 points per shot. So this is a plot of your expected points by shot distance. And I picked a couple of players from the NBA Finals. These are regular season stats, but I want to spend just a minute talking about this. You can see right away, if you're close to the basket, very efficient. And then you see this big mid-range dip. And then right around, I think it's 23 feet, 9 inches is the 3-point line. And you could see this pop in expected points. This is, if you've heard people talk about why a mid-range shot is not efficient and why everyone is trying to take threes and shots at the basket, this is why. This bump here. I'm sure, years ago, whatever some of the first teams were, the Houston Rockets, even like the 7 seconds or less Phoenix Suns, they had some semblance of this type of graph. A couple things I think are really interesting. First of all, Giannis Antetokounmpo, look at this. He's getting almost 1.6 points per shot when he's at the rim, which is unbelievable. And this is kind of, what everyone talks about, where you got to keep this guy away from the rim. This is an unbelievable level of efficiency. Might be one of the best shots in basketball. Giannis close to the rim. Other things that are neat. Well, and then of course you see a big drop for Giannis. So they, when people shake their head, why is he taking a 3-point shot? This is why. You're down here versus up here. And second thing is you see a couple players here. This is Devin Booker. We talked about Chris Paul. They're kind of much more efficient in the mid-range. It's almost not too bad of a shot for them. In fact, like a Chris Paul mid-range shot is, certainly more efficient than like a Giannis 3-point shot. So it's not every player, and some players are much more efficient in the mid-range. The last thing I'd highlight, and then I'll try to take some questions, is you look at Devin Booker here. So Devin Booker, very efficient in the mid-range, but then kind of a little bit less efficient from 3-point. And the reason I just want to highlight this is I remember watching the NBA Finals as someone rooting for the Milwaukee Bucks, and I used to get so frustrated because I felt like the Bucks kept leaving Devin Booker open from 3. And my guess would be they saw something like this, and they realized that a Devin Booker 3-point shot is actually, for him, less efficient than a mid-range shot. So had I seen this, I would have been, less frustrated. So again, I think most people have some semblance of this kind of S shape from just kind of listening to basketball, but here's a way to see it. And just to quickly wrap up, then I'll take some of the questions that I see in the chat here. This package, I think it's great, gets you up and running very quickly. Don't overlook, getting data. This is like a hugely important step in making sure it's good data and cleaning it. Take those computer science classes, take those database management classes, make sure you're very comfortable manipulating data, especially if you're targeting like an entry-level job. Don't overlook this step here, because the statistics looks great, but if your input is not good, then you obviously don't have any meaningful results. We talked about some of the case studies. My contact information, if you jump out to my website, you can find my email. Happy to take questions if you want to get into anything more, or you think of a question later, feel free to contact me. Start with the website. And the very last thing I would say before I take some questions is one other big part of, I think, sports analytics in general, but particularly basketball, is taking the effort to learn the nuances of basketball. Try to, learn like basic stuff like the rules, but even some of the strategies different teams employ. Try to get familiar with the lingo, like dribble handoffs and, different what they call sets or plays. And being able to speak that language, I think, is going to make your statistical analysis that much more powerful and something that someone might be more receptive to. So try to hang around, whether it's your basketball team at your local school. Maybe they'll kind of let you sit in on some practices, whatever. But just don't discount spending some time to learn about basketball itself, and that'll really make you a well-balanced, sports analytics type of person. Okay, so I want to thank you for anyone who's going to drop off now. I do have some questions I'm going to spend time with, but thank you so much for coming today. Feel free to contact me with questions afterwards or anything else. Now, a few questions I missed. Welcome to throw them in the chat. Let's see, I think one question I want to talk about, I got a question on the clustering from Richard. What factors determine what cluster a team is in? It seems like the wins and points scored and given up aren't huge factors in this. That's true. So this is based on the 4 factors. If you remember way early on, this. So these are like the metrics for each team. And so two teams would be similar if they have similar effective field goal percentage, similar turnover ratios, similar rebound, percentage and free throw rate. So the reason they do this is you're basically making the argument that sometimes wins and losses are a little bit random, and you're trying to get at like how a team plays. So this is where, again, might be a little bit of a reach, but if you're the Chicago Bulls, you're like, hey, wait a minute. If you look at like our more efficient stats, we didn't win a lot of games, but we play like the really good teams. So it's actually a way to try to get at, try to remove some of like the inherent randomness and things like wins and losses. So you're right. It is not based on that, and it's trying to actually provide a different perspective. But I would say too, like teams in this cluster are teams that don't score a lot of points and give up a lot of points, and they're all, generally speaking, in the same cluster. So it's not like how many points you gave up and your opponent scored don't have some information, but then certainly when you get like here, these teams are all pretty close, but they're all in different colors. Let's see, another question. Does the expected points account for an and one? So this graph does not. But when you are thinking about how efficient a player is, you certainly want to account for free throws. Because generally speaking, right, a free throw is going to be an extremely efficient shot. So if you think about this here, right, if I'm a Steph Curry and I shoot basically 90% from the free throw line, and I get to take 3 shots, say I get fouled on a 3, then I'm going to have my effective points for that are 0.9 times 3, right? 2.7 points. Extremely efficient possession, right? That's much better than a Giannis dunk. So you want to think about that too. So I think it's a great question, but this particular graph, no, this is just based on play-by-play data. And I think a shot where you're fouled would not be classified as a field goal attempt. So that's something that you can even look into. Like, how might you adjust this for a free throw rate? Like someone like a Giannis, not only are you shooting this good, but he's also getting fouled a lot. So I think that's a very good question, and maybe I'll kind of give it to you as homework. Let's see, there was another question here. Do you use dimensionality reduction? Question from Richard. Is that, I'll come back to this one, Richard. Maybe you can clarify. Is this like in my personal research, or is this specific to the multidimensional scaling? So I'll let you clarify that, Richard, if that's okay. Question was, do you use dimensionality reduction? And I'm just curious if you mean me personally or specific to the application. Question from Jintao. Play-by-play data is obtained also by official agencies. So the play-by-play data, there's 2 ways to get it. If you don't care, if you just want to get up and running, the package BasketballAnalyzeR includes play-by-play data for the Golden State Warriors only for the 2017-2018 season. To get play-by-play data, you can get it for an entire season from this website for $30. That's a ton of data. Think about that. That's play-by-play for every single team. And it's only $30, and you get a giant CSV file. So, I genuinely, I promise you, I don't make any money from big data bald sales. But the other nice thing is if you buy from this website, it's already in a format that you can use with this package. Let's see here. How did you collect this data? Is it possible to collect the same data for another support? So generally speaking, it's a question from my Gianpaolo. And here's kind of a quick answer. So if the sport you're interested in is kind of like a major sport, like a basketball, a soccer, a football, my guess would be there's packages out there. You could also, Gianpaolo, check out Lucas, his workshop on downloading, scraping data from the website, from the internet. But you kind of want to dig around a little bit. And in this case, like there's some data available. I use this package, and then you can buy data. But it's kind of, if it's a different sport, you got to a little bit learn the nuance of that sport. On the flip side, you could really take some of those programming classes, and even like a language like Python, it's really not that much effort to learn how to scrape data from a website, especially if it's like a well-maintained website. So check out Lucas's workshop if you haven't done so already. Check out the recording. But the best way to really get data is to be somewhat competent jumping out there online and scraping it. And you might get lucky if it's like a big sport, like an NBA, there might be packages that help you collect data. And there's like even things for like financial data. By now, there's a ton of packages that help you. So hopefully that helps with your question. Okay, so I think a follow-up from Richard, I was referring to the plot displaying the 8 factors onto a 2D plot. So this, I'll try to answer your question, I think, generally. So here's your, this is for Richard here. This is your original variable. So each player had a total points made, 3 points made, 2 points made. So in other words, this was your input. So each player is going to have 8. So P is 8, right? And what we're trying to do is turn this 8-dimensional vector into a 2-dimensional vector and plot it. And there's a lot of different ways to do that. And I appreciate the fact I'm glancing over this very quickly. But that's effectively what you're doing. So if you look at like a Julius Randle, right, it looks like he's plotted at 0, -5. So whatever he had for this 8-dimensional stats, our algorithm here, our multidimensional scaling says, well, actually, if you plot him at 0, -0.5, relative to everyone else, you get some idea of how different or dissimilar he is versus like RJ Barrett. So hopefully that helps. So it is dimension reduced, right? We started at 8 and now we're only in 2. And right, it's very hard to plot an 8 by 8 dimensional, I can't even visualize that. Hopefully that helps. Richard, Christopher here. Question from Christopher: how do NBA teams specifically utilize this information to improve their rosters? Super broad question, Christopher. I tried to give you some like general ideas how that might happen. Some other examples, right? We'll look at this. Maybe let's say we're general managers, right? You, Christopher, you and me, we're general manager of a team. Our interior defense is not good. Now, something we know, right, is Rudy Gobert is very good defensively. Really hard to get him. Clint Capella is similar to Rudy Gobert. Think about the Atlanta Hawks, right? They traded for Clint Capella. Maybe they ran some type of analysis like this. Not saying they did, not saying they didn't. But this is somewhere you could say, okay, if we can get a Clint Capella, we can get a rough approximation of a Rudy Gobert. It's going to help our defense. Other types of things down here. You try to target certain players. You can kind of compare a couple. Something like, let's see, try to give you another. I mean, the major one, right, is this plot right here. So one thing I think would be really interesting homework for you is give me a James Harden shot chart from, when he first started in the league. I bet he takes a lot of mid-range shots. That'd be my guess. So you could do this, get some data for James Harden, his early seasons, maybe on the Oklahoma City Thunder. Gets to the Rockets say, hey, James, look at this. Now James Harden shoots like this, does not take mid-range shots. That's a way, like, the players specifically, they change the way they play to improve their team. Some of the network analysis, like I talked about some of the cap stuff, but it's a broad question. So I think I'm starting to get a little too starting to ramble a little bit, Christopher. But hopefully that helps give you some ideas. Okay, I think that's it for the questions. Thank you so much. Like I said, feel free to reach out to me. I really like talking about this kind of stuff. So hopefully this was helpful to you. And thanks for the time. And this will also be recorded if you want to jump back later. And of course, don't forget the GitHub website, because then you can really get started. So thank you so much, and best wishes, and certainly good luck to everybody out there who's in the midst of their undergraduate studies and everything else. Thank you.